Welcome to my channel. In this tutorial, we want to treat another aspect of sequence and series under arithmetic progression. We are taking finite arithmetic sequence. We under the definition of sequence and series, we did mention that series can be either finite or infinite, meaning the arrangement of numbers can have end as a finite, or it could be endless as infinite. So let's see how we can deduce that in this episode. Don't forget to subscribe if you're new, like and share. Let's get into it. So by consideration, let's consider the sequence 1, 3, 5, 7, and 9. This is a finite word sequence, meaning the last element is known. Alright, we also define that this is a first term, second term, third term, the fourth, and the fifth. Right? So we have 5 terms. So the fifth term here is 9. The fifth term is 9. And the last element here, or the term, is also 9. So the last term is 9, the fifth term is also 9. Now, you can be asked and say, oh, how many terms are here? Actually, they ask you the nth term. The nth term, how many terms are possible? So in this case, if I have my A to be equals to 1, my D to be equals to the difference between two consecutive terms. 3 and 1 is 2. 5 and 3 is also 2. So we have our common difference to be this. We want to find the nth term. How many terms that are here? So if we know that this is the nth term of a sequence, this is the nth term of a sequence, where the n is standing for the nth terms. We don't know how many terms are there. So now this is going to be equals to first term plus n minus 1 times what? 2. Let's expand this and see 1 plus 2n minus 2. This become 2n, as keeping this 1 minus 2 give you what? Minus 1. So in this case, the nth term, the number of terms present here is what? 2n minus 1. But here we know the number, so we can see that, okay, if I want to find the first term, when I put 1, the first term, that means n is 1. 1 here become 2 minus 1, 1. The second term, so if you put 2 here, you are going to put 2, 2, 4. 4 minus 1, 3. The third term, 3 will be here, 3 will be here, 6. Minus 1, 5. The fourth term, 4, 4, 8. Minus 1, 7. The fifth term. So we can say that the nth term, if n is what? 5, we are going to have u5 to be 2, 5 minus 1. That will be 10 minus 1, which is what? 9. So this nth term is 9. Then the last term is also what? 9. So we can conclude that in any sequence, arithmetic sequence, that is AP, the nth term is also the same as what? The last term. The nth term is the same as the last term. The nth term is only asking how many terms are present. So if there are 5 terms, it means there are only what? 5 elements. The last number will give you the answer you're looking for. So anytime they said you were given a finite AP, which is the sequence, and you are asked to find the number of terms or to find the last term, you should know that the last term is always the same as what? The nth term. So the formula could also be the nth term, which is a plus n minus 1d equals to L. Where we eliminate this, we still have a plus n minus 1d equals to L. If you eliminate this, you still have the nth term equals this. So this is what we want to build into this question. Determine the number of terms. How many possible terms are present in the sequence 5, 11, 17, plenty numbers up to what? 77. So this obviously is a finite word. sequence, meaning all the elements are known, just that there are missing numbers here. If I determine my common difference, add it to 17 in that order, I will get all the elements present. But I don't want to do that. So I can just follow the procedure that says that the nth term is the same as what? The last term. Therefore, we know our A in this sequence to be 5, common difference to be 11 minus 5, and that to be what? 6. Right here, we also know our last term in the sequence to be what? 77. The nth term you're looking for is the n. Because if the n is 4, this thing to you 4. Alright. So that simply means that your L equals to A, which is what? 5. The n minus 1 times D, which is what? 6. Now the L could also be changed to what? 77, since we have the formula already stated. So the L equals to A n minus 1 D. So let's keep this expansion. 6 times n. 6n, 6 times minus 1 will be what? Minus 6. So 77 is equals to 6n minus 1. So I think I can add 1 to both sides. If you add 1 to both sides, you'll be having 77 plus 1 equals to 6n. And this gives us 78 equals to 6 what? N. So we need the n. So we divide through by the coefficient 6. 78 over 6. 6n over 6. That implies that your n is going to be, go here 1. Remember 1. So we have 13. Meaning there are 13 different elements to have the 77 to be the last term. Right? I believe you get the concept. So it means all the elements that are present to make 77 the last term is just 13 different elements. Alright. The next question is to find the 30th term, meaning it goes beyond 77. So the 30th term will be U30 equals 2. So right away from here, we can also have our A plus N, which is 30. So 29D. Don't forget, this is 30, so 30 minus 1. So your A, which all the way we have as what? 5. 29 times D, which we are having as what? 6. So 5, we know this, times this give us 120. This will give you 56, 54. So 174. So 174, when you add, you have 179 as the 30th term. The 30th term. If you continue adding the 6 to each of the term, to get to the 30th position, your answer will be 179. Alright, so this is all about the finite word arithmetic sequence. You can be asked to find the number of terms, you can be asked to find the last term, or the last term will be given to find first term or common difference. So these are the end. If you have the concept being well explained to you, share this video with your learning mate or anybody who like mathematics. Help them subscribe and click on the notification bell for more of these videos. Like and leave a comment. Bye bye.